All right. Good morning. My name is Olivia Bouligny. I go by Liv. I'm also recently transitioning from Air Force service, 21 years as an avionics technician, working on F-16s and CV-22 Ospreys, and now trying to pivot onto something new and hopefully not have to necessarily touch an aircraft again, but who knows. But today for my capstone project, I came up with Proxima Blue. It's meant to detect human presence when you're talking about like heavy machinery and stuff like that. You don't have the best visibility in the driver's seat of big machines, and having the capability of seeing when there's someone around you, I thought would be a good thing to try to figure out. And so I've seen some things in the past with machines and people controlling them and not being able to see exactly what's going on or who is around them, and some people very nearly getting hurt. And so that was kind of my motivating factor for this, to try and have some sort of way to alert the driver that, hey, there's someone around you, take a look around and be cautious. Parts that went into this: particle argon microcontrollers. I got 3 of them so we could have some peripheral devices. The monochrome OLED display to display some data from the scans to see if there's any Bluetooth devices in the area, and some air quality sensors that would be on mobile units attached to a hard hat or a vest or whatever the need would be. And there's a little buzzer on there too, that when the air quality gets to a certain point, it would notify the user that they're in an environment that has a little bit of some sort of chemical in the air, and they might want to be cautious about that. And that air quality sensor can detect, carbon monoxide, alcohol, acetone, and various others. It doesn't list all of them, but as far as design goes, we had one microcontroller to serve as a central device. That one's going to be scanning for other Bluetooth devices in the area, and I set up 2 other microcontrollers that would act as mobile devices. So as I said, meant to be attached to a hard hat or a belt, something that a person that's supposed to be in the area and maybe is like helping you monitor the area or something could use. And then the air quality sensors, again, wired in with it to serve as a warning that the air quality around them is getting a little worse. The code for the central device is just scanning for Bluetooth signals, differentiating between known and unknown devices, and displaying that to the OLED to let you know, hey, there's these people that are supposed to be in the area, but then there's also these other devices detected, so there's probably some other people nearby, so be careful. We're also getting the air quality data from those peripheral devices, and those get published to a dashboard that you can monitor, so you can see if one person is experiencing some worse air quality than the other, they can go check out that area and see what's going on. And then the localized devices were coded to constantly monitor the air quality data and then alert the user, as well as pushing that data to the dashboard. And this is a good look at the dashboard. Have both of the peripheral devices on here showing where they're at air quality wise. The 3D designs, pretty simple for this. I just wanted to create some housings to hold the boards in place so that obviously they wouldn't be flying around and having a chance to get damaged. Underneath there's a little slot for the battery and got a wire channel so the wires don't get crimped or anything by the board. And then there was notches here for the actual sensors so that they fit nice and snug and don't move around as much. So with all that, I made a little video to kind of show some of how this is working. So we'll get right into that.
As we advance as a species, we build bigger, better machines that can do the work faster, more efficient. But with that comes more danger. Equipment becomes more perilous to be around as a human being. And visibility can become more limited when operating these pieces of machinery. So knowing who is around you at all times becomes very vital. Hi, I'm Olivia Bouligny, and I'm here to talk to you about Proxima Blue. When this idea first dawned on me, I thought about how would we be able to best detect a human being nearby. I came upon a stat. 85% of people in the world own smartphones and carry them everywhere. Proxima Blue has a central device scanning for Bluetooth signals constantly and displaying them to an OLED. Peripheral devices can be added to a hard hat or a vest, and these ones in particular have air quality sensors detecting for gases in the area. The air quality sensors attached to our peripheral devices can detect the presence of alcohol, formaldehyde, carbon monoxide, and various other gases. And when it gets a high concentration of that, will emit an audible tone that can be heard right now. This tone is meant to alert the wearer of the device of a hazard in the area. The peripheral devices also transmit air quality data to the main device, which then posts to a dashboard so you can monitor air quality levels constantly. The central device consistently scans for Bluetooth devices, differentiates between known and unknown devices, and then displays that info to the OLED so that you can know exactly who is nearby at all times.
So as with any project, you have your stepping stones, your hurdles you have to get through, and this was no different. The first one was being able to identify and differentiate between scan devices. So I used scanning for kind of the MAC address that was being broadcast, the advertised address. And initially when I was doing the scan, I didn't realize that they were coming in reverse order. So I was like, none of these are matching any of the devices addresses that I have. And then I figured out that they were backwards and had to just reverse which bytes I was looking at in that code. The other part of identifying scan devices that was a problem is I was trying to figure out how to, make a known list for phones so that, people could register their personal devices if they were working for that company per se. The problem with that is I found out a lot of phone companies now scramble the advertised addresses. So there's no predicting what that address is going to be. So I had to kind of just pivot and settle with, we just detect an unknown device and leave it at that. The other thing was the variations in the device transmitters. Discovered signal strength can vary even just by flipping your phone over from where the transmitter is on the phone. So if I was at one distance and getting a signal, I could just stay at that distance, flip my phone over, and I would all of a sudden lose that signal. So that was a little bit tough. And different devices could show different signal strength at the same range. So I had to kind of find that sweet spot where many devices would pick up at a certain distance. And the Argon scan range was limited at default, and I discovered that I can adjust that. And so I boosted the power as well as used an external Bluetooth antenna to help get more signal out of it and be able to pull in more devices. In the future, I would like to work through more in-depth Bluetooth connectivity between the Argon devices. I would like them to be able to get data and share that via the Bluetooth connection instead of this time I had to use the Wi-Fi connection to upload to the cloud. And determining the other variations in the applications of this, possibly using it for security, having a central device maybe at a door. And so if it's 3 o'clock in the morning and it detects a Bluetooth device nearby, then security personnel can go check out that door and see if there's anybody trying to get in or whatever. Electrical line work. Kevin actually mentioned that he had a friend that was talking to him about this, and he said that could be beneficial for him, knowing that, hey, someone just walked up on my pole that I'm on where I'm trying to work on electrical lines, and that might be dangerous to them. Potential uses in farming equipment as well. It's a lot of big equipment. So someone ends up walking up on you and you don't know it. And automated factories is another use case I kind of thought about, like having a floor that's all automated. If you have some detecting devices, it can maybe like go into a caution mode if it detects some human presence that's not normally supposed to be there. And then another thing was more visible and audio warning cues for proximity detection. I kind of focused on being able to display accurate data for devices that were around or not. So being able to make more of a cue to the driver that, hey, there's some warnings to look out for. So thank you all for your time. With that, I would like to open the floor to any questions y'all might have.